The Leave Plan of Room experts has found that, utilizing our new $10 billion toy, it will be seemingly forever before that dream changes into a reality. Assuming it goes as organized, the excursion to Proxima B will expect near 20 years. So, reasonably, it will be an incredibly long time frame before we can affirm if there is, without a doubt, life on that planet. The deep-rooted solicitation of whether we are truly alone in this universe continues. The James Webb Telescope has found a few startlingly human-like things far away from Earth that lead us nearer to the answer. Our excursion for life beyond us has been wild all through each human improvement, such a lot that we have an extensive number of media forming and creating hypotheses concerning this matter. Our wonder concerning our place and sadness in the universe has been unsurprising, like it is saturated within us to consistently look for a friend, regardless of how alien-like we may seem. We may be getting closer to the answers we genuinely need. However, are they truly the answers we are searching for, or are they even more frightening? Oblige us as we research the most recent revelations in the realms of universes and planets on the journey to find something we undoubtedly will not be ready to see. Lights very far away. Experts have found what could be the most significant discovery in history. Back in 2021, when the James Webb Space Telescope, JWST, was planned to launch, an incredibly fascinating speculative question was raised about the limitation of our development. The question was whether, in the future, our telescopes could detect artificial light on another planet, for instance Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was recognized to be tidally locked with an unimaginably extreme day side and night side, like our Moon. A theoretical advanced civilization on Proxima B could transfer power from the day side to the night side using photovoltaic cells that generate power from starlight. In a paper with Manusvi Lingam as one of the researchers, it was shown that the large concentration of day-side solar panels could be detected with future telescopes. Since JWST was additionally developed, it allowed us to expand our search for artificial lights to terrestrial exoplanets like Proxima B. In 2024, the JWST did precisely that. Using its higher sensitivity and broader range of capabilities, it might have found the lights we were looking for, perhaps flinging us into a new wave of human progress. With everything taken into account, let us dive into the universe of planets and exoplanets to understand how this was even possible. James Webb's mission: exploring Proxima B's secrets. From the beginning of recorded history, people have wondered about the universe, what we are, where we come from, and where we go. These are natural yet extraordinarily complex questions that humanity has sought to answer since we gained consciousness. Now, in the era of significant technological advancements, one wonders if we are any closer to answering these questions. If you were to ask a philosopher, they might say we are still at level 0 in understanding ourselves in the universe. However, ask an astronomer the same thing, and you'd see them beam with excitement as they tell you about the latest discoveries humans have made about the cosmos using sharp instruments. These contraptions, often not given much thought by the general public, are a testament to human progress. We now have the world at our fingertips, and the time has come to push forward and bring the universe within our grasp. One such method has been examined by researchers and space experts through advancements in technology. That very technology is responsible for the new discovery of what might be light on a distant planet, light years away. Yes, we're talking about the James Webb Space Telescope, JWST. The JWST is a product of the traditions of human missions into space, built to answer some of the most fundamental questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared astronomy tool has recently begun addressing these inquiries, albeit in small steps. You may wonder, what is Proxima B? Proxima Centauri B, or simply Proxima B, is often referred to as Alpha Centauri. It is a super-Earth exoplanet orbiting an M-type star. Super-Earths, despite the name, are not as intimidating as they sound. These are a class of planets more massive than Earth but lighter than gas giants like Neptune and Uranus. They can be composed of gas, rock, or even a mix of both, and their sizes vary from twice the size of Earth to several times its mass. They are, indeed, super in many senses. Proxima B is a super-Earth and an exoplanet, meaning it orbits outside our solar system. The earliest possible evidence of an exoplanet was noted in 1917, though it drew little interest. However, in 1992, the first confirmed discovery left researchers stunned. Another exoplanet, first perceived in 1988, was officially recognized in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems host more than one planet. These discoveries often orbit M-type stars. To understand M-type stars, you need to know about red dwarfs. Red dwarfs are the smallest stars in the main sequence. These faint stars have low luminosity and are the most commonly found type in the Milky Way. Since brightness is one of our primary tools for planet detection, red dwarfs are challenging to observe. They emit most of their energy as infrared radiation. Returning to Proxima B, its mass is comparable to 1.07 Earth masses. Interestingly, it takes only 11.2 days to complete one orbit around its star, compared to our 365.25 days. You can gauge the size of the star it orbits by noting its position on the electromagnetic spectrum. The star's total luminosity is only 1.6% of the Sun's, with more than 85% of its emitted energy in the form of infrared radiation. Proxima B was first announced in 2016. But why, out of countless stars, planets, and galaxies, does Proxima B captivate so much interest? There are a few key reasons. First, Proxima B is the closest known exoplanet to our Sun. At 4.25 light-years, it is a mere speck in the cosmic scale, yet a significant milestone for Earthlings. Proxima B is also part of a triple star system known as Alpha Centauri. Despite Proxima Centauri's dim glow, the proximity of this system makes it a priority for exploration. What truly piques interest is the potential habitability of Proxima B. Located within the habitable zone of its star, the planet may have surface temperatures suitable for liquid water, a key ingredient for life as we know it. However, habitability is not guaranteed. Proxima Centauri, being an M-type star, is prone to stellar flares. These flares emit high-energy radiation that could strip away a planet's atmosphere or make the surface uninhabitable for complex life. Despite these challenges, the planet's location and characteristics make it one of the most studied exoplanets in the search for extraterrestrial life. The James Webb Telescope's role. The James Webb Space Telescope, JWST, has revolutionized our ability to study distant worlds. Like Proxima being launched in 2021, the JWST is equipped with advanced infrared capabilities, allowing it to detect faint light signatures from distant objects. This includes potential biosignatures, indications of life, or technosignatures, indications of advanced civilizations, such as artificial light. In 2024, researchers used the JWST to search for evidence of artificial illumination on Proxima B. This idea, first proposed by theorists, suggests that advanced civilizations might use solar panels or other light-based technologies to power their societies. The telescope's high sensitivity allowed scientists to analyze the planet's surface and atmosphere for unusual light patterns that could indicate artificial origins. What could artificial light mean? If the JWST detected artificial light on Proxima B, it would be a groundbreaking discovery. This would mean that not only does intelligent life exist beyond Earth, but it also possesses technological capabilities advanced enough to produce detectable light from 4.25 light-years away. Such a discovery would fundamentally reshape our understanding of our place in the universe. However, interpreting such data is complex. Light signatures could also have natural explanations, such as volcanic activity or unusual atmospheric phenomena. Scientists must carefully analyze all possibilities before concluding that the light is artificial. The bigger picture. Proxima B is just one of thousands of known exoplanets, but it represents a broader effort to understand the universe. The JWST and other telescopes are helping us piece together a cosmic puzzle, exploring questions that have fascinated humanity for millennia. Are we alone? If not, what will it mean to find others like us, or entirely unlike us, among the stars? The search for extraterrestrial life is more than just a scientific endeavor. It's a reflection of our deepest curiosities and hopes. Discovering life elsewhere, whether simple microbes or advanced civilizations, would not only answer fundamental questions but also inspire new ones about the nature of existence, evolution, and our shared destiny in the cosmos. Conclusion. As we continue our search, Proxima B remains a beacon of possibility. Whether it holds life, harbors artificial light, or simply serves as a stepping stone in our understanding of exoplanets, its study exemplifies the spirit of exploration. With tools like the James Webb Space Telescope, humanity is pushing the boundaries of what we know and venturing further into the great unknown. The journey is far from over, but each discovery brings us closer to understanding our place in the universe, and perhaps finding out that we are not alone. The structure shows up as possibly, perhaps, one of the most splendid, glorious bodies in the night sky, so to speak, behind two others called Sirius and Creation. In any event, the most enchanting thing about Proxima Centauri b is that it could truly be respectable since it falls under the habitable zone. The potential outcomes involving the star are wearisome, and as such, space experts have taken on the mission to analyze the profundities and limitations of the capacity of the star. That is where the James Webb Space Telescope (JWST) comes in. The 4 basic points of the JWST are: to look for light from the earliest stars and universes that formed in the universe after the Big Bang, concentrate on world formation and progress, handle star and planet development, and focus on planetary designs and the starting characteristics of life. As the JWST continues its assessment of the said exoplanet, we get closer to the completion of these missions, from searching for exoplanets to looking for extraterrestrial life. So what exactly is SET? One could ask, considering that humans have unceasingly been an ambitious species, hitting and catching anything that moves, and even things that don't move. It makes sense that a mission like SETI would appear on such a grand scale. Imagine that God has worked with a tremendous undertaking. With it turn everything considered of gold, we are enriched with the post for banners, much more specifically electromagnetic murmurs from civilizations past anything we could ever imagine. SETI, short for the search for extraterrestrial intelligence, is like the world's most high-stakes game of hide and seek, with our planet as the seeker and the immense universe as the seemingly never-ending hiding spot. It is one of those fields where researchers are cutting-edge Sherlocks, tuned into radio waves and scouring for that subtle high from another universe. We are not trailing behind a few noble individuals. This game of vast sneaking around started precisely in the 1960s. Frank Drake, a man who could make even Einstein say, "Well, that's a sharp treat," pointed a radio telescope at 2 sun-like stars and 2 tuned in. Despite how he was greeted with the sound of silence, Drake's equation, a logarithmic formula to measure how many human civilizations exist in our universe, set up the search. Fast forward to now, and SETI has transitioned from a yard science project to an interstellar mission. Experts use a variety of devices, from the Beast Arecibo telescope to the Allen telescope array, an assortment of dishes that looks like a cutting-edge crop circle. The point is to get that one specific sign, a blip or a mutter, that connects from an alternate universe. These are radio transmissions that SETI consistently seeks after, the kind you could hear on your FM dial, just with a little more stardust. But in 1977 a signal named WOW was received. It was a radio burst so specific that it made the astronomer who detected it yell "wow" in the edges of the information printout. Was it ET calling home? Not precisely clear. In any case, it filled the energy to keep the ears of our giant dishes open. But listening isn't enough anymore. With advancements in technology, SETI now searches for technomark indications of advancement, the kind that would show a human civilization advanced enough to send them. Picture this: an exoplanet washed in the brilliance of city lights or canvassed in solar-based chargers. It's new to sparkle under a foreign sun. SETI's New Age adventure is to identify these artificial lights or current contaminations in unapproachable circumstances, distant worlds, equivalent to finding deserts and covers abandoned in a huge park. These efforts tie directly with the James Webb Space Telescope's mission. The JWST, with its sharp infrared vision, could be the ultimate tool that helps SETI in identifying these technomarks. It's a tag-team effort where the telescope sees the planets, and SETI tunes in for the indications of intelligence. But SETI, though strong, faces its fair share of difficulties. Space is incredibly vast, and science can be as tricky as finding a needle in an intergalactic haystack. There's also the endless speed limit. Signals from human advancements light years away would take eons to reach us. Nevertheless, the possibilities remain and the search continues, enabled by the hope of one day figuring out that, in this grand cosmic show, we are likely not the only players. The new discovery using the JWST may very well be the best find in this hide-and-seek game. This significant discovery could suggest that Proxima B has artificial lights on its obscured side. But does that truly mean it's possible that an advanced civilization exists, capable of using tools like our own? Have we found partners? Are we truly alone in the universe? The overall thought of this exposure is terrifying, as there is so much more to discover. But more than that, the endless number of possibilities is the truly disturbing aspect. We should dive into the details and see exactly what this implies. As we continue to explore the depths of these possibilities, the revelation of artificial lights on Proxima B would be a monumental breakthrough in our understanding of the cosmos. If confirmed, it could reshape our views on extraterrestrial life, suggesting that intelligent beings may have already discovered ways to manipulate their environment in ways that mirror, or even surpass, our own technological advancements. Such a discovery could serve as proof that we are not alone in the universe, challenging the very nature of human existence and our place in the vast expanse of space. However, the road ahead remains fraught with challenges. Detecting artificial lights from a distant exoplanet is no small feat even with the advanced capabilities of the James Webb Space Telescope. The sheer distance between us and Proxima B means that any signals we receive could be faint and distorted. Furthermore, the potential for interference from natural cosmic phenomena, such as radiation or stellar flares, could complicate efforts to distinguish genuine signs of intelligent life from mere noise. Moreover, the idea of detecting artificial lights introduces a new set of questions. What kind of technology might these extraterrestrial civilizations possess? Would their cities or machinery emit light similar to our own, or would their methods of energy production differ in ways we cannot yet fathom? Could they have developed ways to harness energy from their sun or perhaps even tap into the resources of their planet in ways we have not yet imagined? These are questions that could propel the field of astrobiology into uncharted territory, forcing us to reconsider our assumptions about life beyond Earth. The potential discovery of artificial lights would also raise philosophical and existential questions about our future. If we are not alone, what does that mean for humanity's trajectory? Could contact with an alien civilization lead to new forms of collaboration and shared knowledge? Or could it bring unforeseen dangers as we confront beings whose technology and culture are far more advanced than our own? As the search for extraterrestrial intelligence continues, these questions will only become more pressing. With every new piece of data gathered by the JWST and other space observatories, we come closer to understanding the mysteries of the universe and our place within it. The discovery of artificial lights on Proxima B or any other exoplanet would be a defining moment in the history of science, a moment that could alter the course of human history itself. Yet, even if no signals are detected, the pursuit of knowledge will continue. The search for signs of life beyond our planet is not just about finding extraterrestrials, it is about pushing the boundaries of human understanding, expanding our view of the cosmos, and exploring the fundamental questions that have intrigued humanity for millennia. Are we alone? What is the nature of life in the universe? And what does the future hold for us as a species in this infinite and ever-evolving expanse of space? Only time and continued exploration will tell.